So iterators on vectors are random access. So this means that they can be repositioned to any place inside our container. For example, instead of initializing this iterator to the beginning of the position, the initial position right here, I can say that I want position +1. So then iterator here will be positioned to point to randomly assigned place by using begin as a base position and advancing to any location you want inside the iterator. So if we try building it, so you can see this builds fine and it works. Now random access iterators can be incremented and decremented just like pointers, and so they can be added with integers. So we can use integer offset calculations based on the idea that we want to essentially probably start at the beginning of the container and then be able to add integers that would specify either positive or negative advancements in the iterator position. So the iterators are a pretty useful concept, and they have something that can be used with not just standard library containers such as vector, but also with primitive arrays, with strings, and besides vector, list containers and trees. So it's possible to use typedef facility in C++ and declare or give a specific data type, and here you see that it's a vector already parameterized by integer, to specify specify an additional name for this data type. And now we can refer back to constant iterator and iterator by using this already defined data type through the typedef. So basically typedef provides a synonym to an existing data type, and you can now use it with a renamed data type. So sometimes you want to be able to use this type of code and switch between different types of storage. So there this can be swapped for something else to redefine this instantly, and the rest of the code should not need to change. So it's just a typedef trick that you can use to give certain data types new names. And you can see it goes further. It basically says now that we define storage type as vector, now we can use that storage type const iterator as const storage iterator and iterator as this. And so we have all of these new names for various data types. Right here we did not use typedef, so if we wanted to use typedef, once again this would work. Let's just try to experiment with this. So we can say, for instance, that we have typedef this as we can say container type. Okay, and this will be the synonym for vector int, and then we can, I'll just replace some of this code with this new name, container type. Right, so we can say that this is now a container type, and then we can also define this as taking it a little bit further, say typedef container type iterator, just like we have in our example. We can just give it container type iterator. So you see that these names could be reassigned different identifiers, so using typedef. So here we should be able to use this specific new name for the type and declare our iterator. So it depends on your software and your situation whether this is something useful and something that could be made more generic when you want to specify different data types. Usually when something is parameterized by the type, by the specific type like this, then you begin to maybe try to generalize so that you have to change it only in one place, and everywhere else it just be using your own identifiers. So this is just typedef facility that you should be aware of, and this is perhaps good a place where this can be used. So our code should not change at all if I try building this. Okay, so it builds the same way, and if I run it, you see that it executes exactly the same way as we did before. Okay, so STL, standard library, once you learn how the basics work, it's pretty useful, efficient, and simple to use. It also allows you to, when you're learning standard library, you begin to understand the philosophy of STL containers. And iterators are a very powerful feature to access individual elements and specify ranges of elements using containers. So that's a good facility to use and to be aware of its existence. And if you need to use standard library algorithms, which we will cover in the second part of our standard library coverage, iterator is pretty much the connection between algorithm functions and containers. So that's definitely something that we have to be able to use.